Hello everyone, welcome back. This is Mr. Osem Wasapi, and in this video we'll be looking at limits, and in this aspect we'll be basically looking at how to evaluate limits. So the question might be first, evaluate this limit. So now how do you do that? So I'll show you all the methods you can use to evaluate a limit. Now, just food for thoughts, you need to understand this. When it comes to evaluating limits, what you're trying to avoid is the statement undefined. You don't want your function to be 0 over 0 or even something over what? 0. This is something you're trying to avoid. You also don't want anything of root of negative something. These are things we avoid when it comes to limits. Never have all these conditions. We don't want them in our life of limits. Alright, so with this said, let's look at all the possible ways of evaluating a limit. Okay, so I'm going to teach you 5 basic ways of finding a limit. And in method 1, this is just where we plug in. So I call this the plug-in method. Okay, so what I want you to understand is this. Say you have a limit as x approaches c of a function f of x. And you want to evaluate this guy. So you can first start by applying the first method, plugging in, that is. So all you have to do is say, okay, let me try to evaluate my function at x is equal to c and see if it's defined at the point x is equal to c. And if so, then that means that is your limit. So remember that. Now basically you want to understand this just by words. Let me show you an example. Okay, so say you have an example where you're saying limit as x approaches 4 of a function that is x squared minus 2x minus 3 over x squared minus 9. Alright, so now what are we going to do? Basically what we do is simple. We just plug in. So one thing you have to understand is this. Once you begin to plug in the limit as x approaches 0, this guy here gets removed. So we'll say x, let's let x equal to what? 4, and see what we get. So here we're going to have 4 squared minus 2 by 4 minus 3 over 4 squared minus 9. Alright, so if we simplify this, we're getting 16 minus 8 minus 3 over 16 minus 9. Okay, 16 minus 8 minus 3, that gives you basically a 5. So you end up having 5 over 16 minus 9. That would be roughly 7. Alright, so 5 over 7 is basically your answer because you don't have any condition where you're having 0 over 0 or something like 5 over 0. You're having 5 over 7. And 5 over 7 is a defined point. So the limit of x approaching 4 of x squared minus 2x minus 3 over x squared minus 9 is literally 5 over 7. And that's what you just have to do when it comes to plugging in. Just get the value that you have, plug it in and see if it works. If it gives you something defined, then literally that will be your what? Limit. Don't forget that very, very important point. Okay, so what we'll do next is to look at another example and see what we can do. Okay, say you have a limit as x approaches negative 1 of x squared minus let's say 9 over x squared minus plus 1. Okay, let's try and plug in and see what we can get. So it's going to be negative 1 squared minus 9 over negative 1 squared plus 1. So this will just give you like 1 minus 9 over 1 plus 1. And this will just give you 1 minus 9, that is negative 8 over 2. This, in the end, gives you minus 4. And this will be your limit. Once you plug in, gives you a value that is defined, then that will basically be your limit. Okay, let's look at another method. So the second method is called factorization. So this is just where you factorize what you have and see how best you can simplify it. So this implies that if plugging in doesn't work, try and factorize. Maybe it can work. So suppose, say you have, let me just start with an example to make you understand. Suppose you have this limit as x approaches what? 3 of x squared minus 2x minus 3 over x squared minus 9. So basically, if you try to plug in, let me just show you. So if I try to plug in here, what will happen is this. I'll have 3 squared minus 2, 3 minus 3 over 3 squared minus 9. So this will be undefined because at the bottom I have what? 0. 3 squared is 9 minus 9 is 0. So this is literally undefined. So at x is equal to 3, the function is indeterminate, which means it's undefined, and the limit does not exist. But now, if we try to factorize this, what will happen? So let's try and factorize and see what will happen. So remember, we're having the limit as x approaches what? 3 of x squared minus 2x minus 3 over x squared minus what? 9. We can try and factorize the top first. So for the top, we can just drop data and see x squared minus 2x minus what? 3. Remember, we have sum and product rule. The sum is minus 2, the product is minus 3. And what are the factors? Well, the factors, okay, let me do that, minus 3. Now, the factors would just be 1 and minus 3. Remember, if this guy is having a coefficient of 1, you can do up the easy way of just saying x plus 1 and x minus what? 3. So that's for the numerator. So for the denominator, we can also do a difference of two squares, that is. And you know, x squared minus 9 will just be x minus 3 and x plus what? 3. So if we put this together, this will be lim as x approaches 3 of the numerator is x plus 1, x minus what? 3 over x minus 3 and x plus what? 3. This cancels with that, and you end up having your limit as x approaches what? 3 of x plus 1 over x plus 3. Okay, so it's like limit of x approaches 3 of x plus 1 over x plus what? 3. Then all I have to do is try and plug in. So we let x equal to what? 3. So we have 3 plus 1 over 3 plus 3. So this will just give us 3 plus 1 as 4 over what? 6. And basically our final answer will be just something I will get when we reduce this. Okay, 2 there is actually 2. 2 there is 3. So our limit will be 2 over what? 3. As simple as that. Alright, so in this video we'll just look at 2 basic methods. In the next video I'll make, we're going to look at the other methods that we have. Alright, don't forget to like and subscribe. My name is Mr. Hussein Mosabi. Remember to strategize before becoming a statistic, and let's try and push for that A+.